Most people think the next battery breakthrough will be a simple headline: longer range, faster charging, lower cost. But what if that's the wrong way to see it? What if the real story isn't the battery at all? What if it's the material behind it, the one no one is watching closely enough? Because in the last few days, a phrase has started circling: silver shock. And it points to a possibility that feels almost impossible at first. The next leap in battery tech could make silver, yes, the same silver people associate with coins and jewelry, one of the most fought over industrial resources on Earth. Here's the mystery. Samsung's new battery direction doesn't just promise performance, it threatens to reroute the global supply chain. When a tech giant commits to a new pathway, markets don't wait for factories to open. Suppliers lock contracts, prices react, and competitors scramble to redesign. If silver becomes even a small but essential ingredient in next-gen cells, the question stops being, can we build it? And becomes, can the world source it without breaking everything else? And that's where it gets uncomfortable. Because silver isn't only a battery metal, it's already being pulled hard by solar panels, electronics, and high-end manufacturing. So if Samsung's move accelerates demand at the wrong moment, we're not looking at a normal product launch. We're looking at a chain reaction, one that could decide who gets the next generation of energy and who gets left behind. The battery race that set up the silver shock. For 3 decades, the world has been running on the same core idea: lithium-ion batteries. They powered the smartphone era, then quietly became the engine of the EV boom. But lithium-ion has always been a compromise: high energy in a small package balanced against heat risk, slow charging. Under stress and gradual degradation, every major player, Tesla's partners, Chinese cell giants, and the big Korean manufacturers, has chased the same dream: a chemistry jump that breaks the trade-off between safety, speed, and capacity. That's why the phrase next-gen battery is never just a tech headline, it's a control of the future headline. Whoever cracks the next standard doesn't just sell batteries, they influence automakers, grid storage, device makers, and national supply chains. This is where solid-state batteries enter the story. The concept sounds simple. Replace the flammable liquid electrolyte with a solid material, and suddenly you can unlock better safety and potentially higher energy density. But the moment you try to scale it, the real problem surfaces: lithium metal. Lithium metal anodes are the jackpot for energy density, but they behave like a dangerous shortcut. Undercharging, lithium can deposit unevenly, forming dendrites that pierce through interfaces and short the cell. That's why solid state has lived for years in a strange space. Always the future, always one major barrier away from mass production. And that barrier wasn't marketing, it was physics, reliability, and manufacturing repeatability. Samsung ES role matters because it sits at the intersection of advanced R&D and industrial scale. When Samsung's research groups started publishing progress on stabilizing lithium metal behavior, it wasn't just academic curiosity. It was a signal that a large manufacturing ecosystem was preparing for a leap. One of the most intriguing directions involved guiding lithium deposition with a silver-based composite layer, which is exactly why people started whispering silver shock. Because silver isn't just any material you sprinkle into a lab cell, it also globally traded industrial metal already demanded by electronics and clean energy manufacturing. If a company like Samsung pushes a design pathway where silver becomes a reliable stabilizer for next-gen cells, the story immediately expands beyond battery performance. It becomes a supply story, a pricing story, and a geopolitical story, setting up the next question we can't ignore: what happens when the world tries to scale a breakthrough? And the key ingredient is suddenly scarce. The paper that lit the fuse. The silver shock didn't start with a stage keynote. It started in a lab with a stubborn question: how do you unlock lithium metal energy density without creating a battery that destroys itself? In March 2020, Samsung researchers published a striking result in Nature Energy, an all-solid-state lithium metal battery design that used a silver-carbon Ag-C composite at the anode to reach high energy density while maintaining long cycling. Silver wasn't a luxury ingredient, it was a control tool. The Ag-C layer helps guide how lithium forms at the interface, reducing the conditions that trigger dendrites and early failure. In Samsung's own explanation, the composite is ultra-thin, only micrometers thick, yet it changes the battery's behavior in a way conventional lithium-ion cells can't copy easily. It also reframed the conversation from invent a miracle electrolyte to engineer the interface where failure begins. But research only becomes disruptive when it maps to manufacturing. Solid-state batteries have been promised for years, yet scaling keeps breaking the dream. Brittle interfaces, poor contact between layers, and performance that collapses outside perfect lab conditions. The Ag-C idea mattered because it pointed toward repeatability, something the market values more than hype. If you can stabilize lithium metal with a designed interface, you can build thinner anodes, pack more active material into the same volume, and potentially improve safety by removing flammable liquid electrolytes. That, in turn, changes charging behavior and thermal management, which changes how EV platforms are engineered and how consumer devices are designed. So a material choice inside one cell can ripple outward into entire product roadmaps. Then came the second domino. Samsung SDI moved from paper to pilot. The company built an all-solid-state pilot line called the S-line, supplied sample cells to customers in 2023, and publicly targeted mass production around 2027. A date like that is a signal flare. Supply chains don't wait for factories to open. They pre-position. Procurement teams ask what materials will be critical and whether those materials have substitutes. Competitors test alternative stacks that avoid new dependencies. Traders watch for demand shocks years before the first mass-produced cell ships. And silver, already heavily used in electronics and clean energy hardware, suddenly looks less like a commodity and more like a bottleneck. That is the origin of the phrase, silver shock. The moment a promising battery pathway hints that the next breakthrough could be limited not by science, but by what the world can source, refine, and deliver at scale. Even if each cell uses only a little silver, scale multiplies it, 1. Factory becomes 10, one model becomes a fleet, and the thin layer becomes tons. When that realization hits, the story stops being chemistry and turns into finance with contracts at stake. When scale turns a breakthrough into a supply shock. At first, Samsung AOS silver carbon idea looked like a clever interface trick, an ultra-thin layer that helps lithium metal behave in a solid-state cell. But the moment Samsung SDI began talking about real-world manufacturing timelines, the meaning changed. A pilot line isn't a science project. It's a signal to the entire industrial ecosystem that procurement planning needs to start now. Samsung SDI has publicly described its all-solid-state S-line pilot efforts and said it supplied sample cells to customers in 2023, while aiming for mass production around 2027. And this is where the first hidden tension appears. Even if the silver content per cell is small, scale multiplies small numbers into big constraints, because batteries aren't produced in thousands. They're produced in millions, then tens of millions. Once engineers validate a design path, supply chains have to guarantee it can be repeated consistently at factory speed. That's the moment a materials choice becomes a materials dependency. Now layer that dependency onto the silver market we already live in. Silver isn't waiting around unused. It's already a workhorse metal for modern industry. According to the World Silver Survey 2025, the silver market ran a deficit in 2024, with demand exceeding supply by about 148.9 million ounces. In other words, the world was already consuming more silver than it produced, leaning on above-ground stocks to close the gap. And industrial demand isn't shrinking with time. It's being pulled by electrification, grid build-out, electronics, and clean energy hardware. This is the second tension. When a market is structurally tight, a new, fast-growing use case doesn't need to be huge to matter. It only needs to be inelastic. If silver becomes non-optional for certain high-performance battery architectures, buyers don't treat it like a price-sensitive input anymore. They treat it like oxygen. That SY silver shock isn't just a catchy phrase. It is the predictable third act of a tight supply story. When markets sense a future squeeze, behavior changes before factories hit full output. Long-term contracts get locked, inventories get hoarded, and everyone else downstream feels the pinch. You can see how quickly sentiment can translate into price action. Reuters reported silver hitting fresh record territory in December 2025, with spot silver around $67, $69 Aus in those late December moves. And here's the twist that keeps viewers glued. Even if Samsung AS silver-linked pathway ends up using less silver than people fear, the shock can still happen. Because supply chains react to risk, not certainty. The moment enough big players believe silver could become the bottleneck, the scramble begins, and by the time the public notices, the real disruption is already underway. The breaking point, when everyone needs the same metal. Here's where the story stops being theoretical and starts becoming a collision. Silver isn't sitting in a warehouse waiting for the battery industry to discover it. It's already allocated, quietly across multiple industries that each believe they're the priority. Solar manufacturers want it because it's essential for conductivity in many. PV designs. Electronics makers want it because it's reliable, highly conductive, and already built into countless components. Medical and industrial systems want it because it performs under stress and corrosion. Now add the battery race on top, and you get a rare kind of pressure. Not a shortage caused by one booming sector, but by several growing at once. And when multiple industries compete for the same input, the market doesn't negotiate politely. It forces a winner through pricing, contracts, and political influence. The breaking point usually arrives in the same way every time, The moment demand becomes must buy. A company can delay buying aluminum if it spikes. It can swap plastics. It can redesign packaging. But a next-gen battery supply chain can maybe buy critical materials if the chemistry depends on them for stability. Once a design is validated, procurement shifts from optimized cost to secure supply. That's when long-term contracts tighten the market, suppliers prioritize their biggest clients and smaller. Manufacturers get squeezed. Suddenly, it's not just that silver is expensive, it's that delivery windows stretch, quality specs become harder to meet, and every factory schedule starts depending on a metal you used to ignore. Even rumors of that future can trigger hoarding behavior, where companies stockpile just in case, making the shortage feel real before it fully is. And the most dangerous part? This is when the system starts making decisions that lock in the shock. Automakers don't like uncertainty, so they push battery partners to guarantee materials. Battery makers don't like uncertainty, so they pressure refiners and traders. Governments don't like uncertainty, so they talk about strategic resources and domestic supply. Step by step, everyone tries to protect themselves, and that protection becomes the very thing that tightens supply for everyone else. It's a loop. Fear creates stockpiles. Stockpiles create scarcity. Scarcity creates higher prices. Higher prices create more fear. That's how a thin layer of silver in a lab concept becomes a global flashpoint. And once that loop begins, the next phase is inevitable. The fallout, companies scrambling to redesign, suppliers choosing sides, and the market punishing anyone who didn't see the bottleneck coming. The fallout, when the supply chain starts choosing winners. The first fallout isn't a factory shutdown, it's quieter and more damaging, procurement panic. Once a material looks like it might become essential for the next wave of batteries, the biggest players move first. They don't wait for confirmation, because waiting is how you lose allocation. They lock multi-year contracts, pay premiums for guaranteed delivery, and build buffer stock that never hits the open market. That behavior instantly tightens the spot supply for everyone else, especially smaller manufacturers who can't prepay, can't outbid, and can't sign gigantic offtake deals. And this is how a breakthrough becomes a disruption, not because silver disappears overnight, but because access becomes tiered. Top customers get stable supply, everyone else gets volatility. Then the pressure spreads sideways. Solar and electronic suppliers that already rely on silver suddenly find themselves competing with a new category of buyer, battery manufacturers chasing strategic security. Prices don't just rise, they become unpredictable, moving on rumors, projections, and procurement moves. This is where silver shock starts reshaping decisions that have nothing to do with batteries. A solar firm delays a build-out because margins vanish. A manufacturer changes designs to reduce silver content, but performance slips. Smaller suppliers get squeezed between fixed-price contracts with customers and rising input costs they can't pass along. And while the public sees only the headline, silver is up, industries see the real damage, missed deadlines, redesign costs, and long-term uncertainty that forces conservative choices, even when innovation is needed most. Finally, the fallout turns political, because supply chains always do when they feel fragile. Countries don't like depending on inputs they can't control, and companies don't like being exposed to geopolitics. So the same playbook appears. Calls for strategic materials, pressure to localize refining, incentives for domestic sourcing, and behind. The scene's competition for long-term deals. But here's the twist. These moves don't immediately solve the problem. They often lock the market into scarcity behavior. Because once governments and major firms treat a metal as strategic, stockpiling becomes rational, and substitution becomes slower. That's when the story becomes bigger than Samsung. Even if Samsung's silver-linked battery pathway ends up using less silver than the market fears, the shock can still land, because the scramble is driven by risk perception. And once an industry starts behaving like the bottleneck is real, it becomes real enough to disrupt everything downstream. The failed fixes, why the easy solutions don't work. When a bottleneck appears, or the world reaches for the same 3 fixes, mine more, recycle more, substitute fast, and almost every time, those fixes fail at the exact moment they're needed most. The first instinct is just increase supply. But metals don't scale like software. New mining projects take years of permitting, financing, and infrastructure. And silver has an extra complication. A lot of it is produced as a byproduct of other mining. That means you can't simply decide to produce dramatically more silver without the economics of other metals cooperating. So even if prices surge, the supply response often arrives late, after the shock has already forced redesigns, delays, and contract battles. The second fix is recycling, especially because it sounds clean and fast. But recycling isn't a magic button either. You need collection systems, separation processes, and refiners capable of delivering the purity required for advanced manufacturing. Even when the technology exists, the scale rarely does, and recycling becomes hardest precisely when demand is exploding, because most of the silver you want to recycle is still locked inside products that returned to the system for years. Old electronics, industrial equipment, legacy panels, devices still in use. So the industry finds itself in a trap. Everyone agrees recycling is part of the future, but it can't stabilize the present. That gap between good idea and industrial reality is where the shock lives. The third fix is substitution. Use less silver or use something else. And yes, companies will try. But substitutions in high-performance systems usually come with trade-offs: higher resistance, lower durability, different failure modes, new manufacturing steps, new quality control risks. The same is true in next-gen batteries. If silver is part of a design that improves stability at the interface, removing it isn't like swapping a screw. It can change how lithium deposits, how the cell ages, and how safe it remains across temperature swings and fast charging. That's why failed fixes don't fail because engineers are lazy. They fail because the system is constrained by physics, time, and economics all at once. And that sets up the next twist. When the obvious fixes don't land, the market does what it always does. It forces adaptation through pain. Prices spike, supply gets rationed, and entire industries pivot under pressure, not preference. The pattern. Silver shock isn't new, it's the same crisis, wearing new clothes. If you've watched any supply chain panic in the last decade, you already know the rhythm. First comes the breakthrough, a new design that promises better performance. Then comes the optimism, we'll scale it fast. But the real story always hides in the inputs, because innovations don't erase scarcity, they relocate it. Samsung's silver-linked solid-state pathway is a perfect example. Once a company signals a serious timeline, like Samsung SDI, guest push from pilot samples in 2023 toward mass production around 2027, markets don't have to wait for the first mass-produced cell to roll off a line. They front-run the risk, they lock contracts, they start pricing in a future where one material becomes non-optional. And that's when silver shock stops being a battery headline and becomes a financial event. Now look at the data that makes this so explosive. The silver market has not been comfortably balanced. It's been structurally tight. The World Silver Survey 2025 describes a deficit of about 148.9 million ounces in 2024, meaning demand outpaced supply and the gap had to be filled from existing stocks. At the same time, industrial demand keeps pressing upward. The 2025 release tied to the same survey data reported industrial demand hitting a record 680.5 million ounces in 2024, driven by the green economy, electrification, and tech hardware demand. In other words, silver isn't waiting for a new industry to discover it. Silver is already being eaten alive by the industries that currently exist. So when a next-gen battery path even hints at adding more demand, it's not adding weight to a calm bridge, it's adding weight to a bridge that's already creaking. And you can see how fast that fear translates into real-world shock. On December 22nd, 2025, Reuters reported silver hitting an all-time high near $69.44 Oz, up roughly 138% year-to-date, fueled by strong investment demand and supply issues. That's the repeating pattern. When people sense the bottleneck, price becomes the rationing mechanism, and price then becomes the headline that pulls in even more attention. Here is the uncomfortable parallel. This is exactly how past critical material moments evolved: panic buying, contract wars, redesign races, and then a split between winners who secured supply early and losers forced into second-best solutions. So the real question isn't, is silver in the battery? The real question is, how many industries can fight over the same metal before something breaks? The silver shock isn't just a catchy phrase. It's a warning that the next battery leap could be limited by materials, not imagination. Samsung's silver-linked solid-state direction suggests a future where breakthroughs trigger market tremors long before mass production. And once a critical input looks scarce, the system doesn't slow down evenly. It picks winners through contracts, pricing, and politics. 3 takeaways. 1, innovation relocates bottlenecks. Today it may be silver, tomorrow another overlooked metal. 2, supply shocks start early. Pilot lines and public timelines move procurement and prices years ahead of factories. 3, the energy transition repeats the same pattern. Multiple booming industries converging on the same finite resources. If silver supply tightens, expect redesign races, stockpiling, and sudden volatility. The open question is simple: will smarter chemistry reduce dependence, or will scarcity dictate what scales next? Either way, watch the inputs, not the headlines. Comment silver shock and tell me what you think: battery revolution or materials crisis. Subscribe for deeper explainers where we trace the hidden inputs behind breakthrough headlines, compare real timelines, and spot supply chain signals before everyone else notices. Hit like so YouTube knows you want more supply chain breakdowns like this today.